Spectral Densimeter, DS52X series, integrated physical positioning hole to help users achieve fast and accurate positioning. High repeatability accuracy, repeatability less than or equal to 0.02. The DS52X series supports a choice of 5 measuring calibers, more than 30 measurement parameters, nearly 40 kinds of evaluation light sources to choose from. Support WeChat mini program, Android, iOS, Harmony OS, app, use the powerful PC-side color management system Color Expert.
DS52A Spectral Densimeter, Operation Video. Power on and off. Short press the measurement button for 1 second to turn on. Press and hold the measurement button for 3 seconds to shut down. Black and white calibration. Click Settings Calibration. Calibration can be performed directly according to the prompts. You can also calibrate after the calibration validity period has expired. Click to calibrate. Align the test port with the white calibration plate for white calibration. Calibrate by pressing the measurement button on the back. Calibration is successful, then perform black calibration. Align the test port with the black cavity for black calibration. Calibration completed. Color density function. Color density function introduction. Before measuring color density, make sure the light source and angle are D50 and 2 degrees respectively. Click Settings Measurement. After turning the page, you can see the angle and light source. Click to switch angles. There are nearly 40 kinds of light sources. Just click on the light source and select the light source you want. After setting, click Color Density. Click the Select Features icon. Provide color density or densities, area increase, overprint, print contrast, tonal error and grayscale. 7 measurement functions. Color density demonstration. Click the icon in the upper right corner to select the density color. Optional automatic recognition or individual measurement of CMYK spot colors. Auto mode demonstration. When measuring samples in automatic mode, it can automatically identify CMYK based on sample measurements. When measuring black samples, K will be displayed. If measuring yellow sample, Y will be displayed. If red sample is measured, M will be displayed. When measuring blue samples, C will be displayed. The above is the automatic mode measurement. Spot color density measurement. All density demos. All densities, ICMYK spot colors are displayed together. M the measuring port of the instrument. Add any color to measure. Introduction to color density settings. Click on the measurement conditions. Select M0, M1, M2, M3. Click Density Status and select ISO Status TEMAI. Click Density Base White. Select Absolute Density and Relative Paper. Click Density Accuracy. Respectively represent the 2 and 3 decimal places after the measured value. Click on the dot area and there are 3 coefficients to choose from. Click the dot area to increase and you can set the percentage of color blocks 1, 2 and 3. Click Overprint to choose from 3 measurement methods. Introduction to Outlet Area. Dot area is also called tone value. It refers to the ratio of the sum of the areas of all outlets clustered on a unit area to the total area. Reflects the degree of ink coverage and dot area measurement. Displays the hue value of the selected color, requiring 1 solid and 1 hue measurement. Let us measure the paper first. Align the test hole with the white paper part for measurement. Measure solid color patches. Measure the color patch corresponding to the measured field. View hue value data for a hue patch. Continue with other color patches that correspond to the measured field, or touch the solid patch on the left screen and measure another solid patch. Introduction to network area increase. The increase in dot area is also called the increase in tone value. It refers to the difference between the actual dot area of the tone color block and the corresponding dot area on the printing sample. Just measure the corresponding color block according to the prompts. Introduction to overprinting function. This function is a physical quantity that measures the degree of ink overprinting. The higher the value, the better the overprinting effect. Measure first ink density. Measure second ink density. Measuring to color overprint density. Introduction to printing contrast. This function is used to control the indicator that adjusts the image to darker tones. Can determine the standard ink supply amount for proofing and printing. Measure real area. Measure dark tone density. Introduction to hue error and grayscale. Hue error H is the amount that indicates the degree of hue shift caused by the inclusion of other color components in the primary color ink. Grayscale G means that the ink contains achromatic components to make it look less saturated. CMYK contrast measurement. Select all densities in the selection function. Standard sample measurement. Click the T icon to measure the sample. This is the difference in color density between the two color patches. Color measurement function. First set the light source and angle to D6, 5 and 10. Find the angle and light source in the settings and adjust them. Click on the color measurement to measure the LAB value of the blue color block. Click the T icon to measure another color for comparison. As shown in the picture, the color difference is unqualified and it also shows the color bias such as more white and less black. More white and less black means that the second sample has more white and less black than the first sample. Click the curve icon to view the reflectivity value every 10 nanometer. Click the Save icon to save the data. Tolerance settings. Click Settings Measurement Tolerance to set the tolerance of LABCH and color difference formulas respectively. Tolerance the user's tolerance for sample color difference. The instrument defaults to 2.0. If the color difference is less than the tolerance, it will be displayed as qualified, and if the color difference is greater than the tolerance, it will be displayed as unqualified. Users can modify the default tolerance value according to their requirements for product color difference. The smaller the tolerance value, the stricter the color difference of the product. Data function introduction. Users can view historically saved data in the data function. You can also use the historically saved standard sample data to call up the color difference measurement. Demonstrate how to measure color difference with only LAB value. Click the plus button. LAB values can be manually entered. Save as a standard sample, and you can call this standard sample for color measurement. How to set the measurement button. The instrument can measure by pressing a button. Compression measurement is also possible. Press measurement requires loosening the positioning plate buckle. In Settings Measurement, find the measurement button. 3 measurement modes to choose from. How to call up the desired measurement parameters. Click Settings Measurement Display Parameters. Just turn the page and select the desired parameter. Select R, G, B parameters for demonstration. After selecting, return to color measurement to measure. How to set up UVS. Click Settings Measurement, turn the page to find UV settings. Once found, click to switch the UV switch status. How to switch caliber. Demonstrate the operation of switching from small caliber to large caliber. First, remove the 5 mm diameter plate. Then replace it with an 11 mm caliber plate. After replacement, the caliber paddle should be buckled to the M position. Not to change to a large diameter, turn the dial to M, and to change to a small diameter, turn the dial to S large diameter. Size is 11 mm, Small diameter sizes 5 mm, 3 mm. Finally, find the caliber selection on the Settings Measurement switch page. Confirm whether the aperture size displayed in the aperture selection is the same as the one you want to change. If not, click Switch. After changing the caliber, recalibration is required. The above is the operation video of the spectral densimeter.